Hello everyone. I Devanshu Rai, and today I will give a demo lecture on topic limits. Okay. So, topic is limits. Limit is one of the most important and fundamental concepts that we need to understand before entering to the vast world of calculus. Okay. So, on this topic is so much important that on this topic is used to define a very important concept in calculus like derivatives, integrals, and all. Okay, so that's why before understand moving towards this differentiation and integration, we need to understand the concept of limits. Okay, so firstly, I will give you the flow of lecture. Okay, what would be the flow of lecture? Then I will move according to the that flow of lecture. Okay, so flow of lectures. Starting with intuition, I will give you the intuition or intuitive idea of limits. Okay, next I will give you the definition of limit, the textbook definition of limit, and third part and the most important one is the motivation behind the limits, why there is a concept limit. Okay, why we need this concept of limit. Okay, so this motivation part is very much important and mostly students struggle in this part only. Okay, so let's first move to the intuition part. To understand the intuition, what we will do is we will take a particular scenario, we will consider a particular scenario, and the scenario is like suppose you are moving, you are walking, and you are walking towards the door. Okay, there is a path and there is a door, and you are walking towards the door. So at each step, what you are doing, you are getting closer to the door. Fine. So let's say at first observation, t is equal to 1 observation, the distance between you and the door is around 2 meter. Okay, now after some time at the second observation, the distance between you and the door is around 1 meter. Fine. Again I observed you, and at the third observation, let's say you are very much closer to the door but as the previous one, and now the distance is around 1 centimeter. And after some time, or let's say at fourth observation, it seems like you have reached the door, but here the catch is practically there is a distance between you and the door, and the distance is not zero yet. So let's say the distance is around 1 millimeter. Okay, so this is the scenario. Okay, got the scenario. So there is a person that is moving towards the door, and its step he is getting closer to the door. Fine. So what's the idea here? What this scenario wants to convey about the idea of limits? Okay, so to get into that, I will ask you a simpler question, and the question is, have you reached the door? Question is, have you reached the door? And what would the answer? Answer would be no, I have not reached the door. Okay, but yes, we got closer to the door. We got closer to the door. So we have not reached the door, but yet we got more closer to the door. Okay, fine. Now the main part comes. So idea that I want to convey from this scenario is getting closer to something but not necessarily reaching it. This is the idea. So getting closer to something but not necessarily reaching it. So here the main keyword is getting closer and not reaching it is the main keyword that we need to understand. And on this idea is what mathematician defined limits. Okay, so this idea will help us to understand limits better. So idea is getting closer to something but not necessarily reaching it. It means we are only closer to that value, we have not attained that value, we have not our input is not equal to that value in mathematical terms, if we say. Okay, fine, the idea is clear, getting closer to something but not necessarily reaching it. Okay, fine, the idea is clear. But how this idea is mapped to the mathematical world, how this idea is used in mathematical world, and how this idea is used to define limits. Now the next question arises would be this. Okay, so to understand this question, to answer this question, what we will do, first we will discuss the definition of limit, we will understand the mathematical definition of limit, and from that we will connect this idea and with the help of example. Okay, so let's move to the definition rounds. So definition. Okay, so what value our function, say f of x, approaches as our input, say x, gets closer and closer to a particular value. Okay, say a. So what value our function, say f of x, approaches as our input, say x, gets closer and closer to a particular value. So what's happening here? Here there is a input, say x, which is getting close to something, let's say a, and we are here want to know how this change in input, how this getting close to some point a is affecting our f of x. Here how change in x towards a is making our f of x approaching to a particular value or not. So this is the definition, or this is the basic idea that we use in maths to define limit. So first of all, let's understand the notation. Okay, so the notation that we use is this limit, and we write here like x arrow a and f of x is equal to L. Now, okay, how to interpret this notation? So to interpret this notation, let's break it. Okay, so first of all, let's take this part, x arrow a. So what this part means? This part means x tends to a. We say x tends to a, meaning x is approaching to a but not equal to a. And this is most important point that we need to understand. X is close to a, x is approaching to a, but x is not equal to a, and this is something we always always remember, that here it means x is not equal to a, x is just closer to a. Okay, and here f of x is the function that we are observing, of which behavior we are observing. Okay, and now the next part and the most important here is L. So what here L means? So here L is what we call limit. Okay, so what L here is? L here is the value that our function f of x approaches as x gets closer to a. So as x gets closer to a, the f of x is also getting closer to something, to some value, and that value to which f of x is getting closer is what we called limit of a function. Okay, so this is the definition. So what is the definition of limit? Suppose we have a function f of x, and suppose we fix a particular point a, and now what we are doing, we are taking some points which are closer to a, and we are getting closer by each step towards a. Okay, and now we are observing how getting closer to this a, we affecting our function f of x, and how this f of x move as x moves to a, and the value that f of x is getting closer, that value is what we call limit. Okay, so basically what limit is giving us, limit is actually helping us to understand the function better around a point a. Suppose there is a function of x and there is a point a. Now limit is helping us to understand how this function behaves around this point a. So this is the main idea, this is the main motivation, or this is the main why, that is why limit is defined. So limit, the main property of limit is what? So the main property of limit is, limit helps us to understand the behavior of a function at a particular point a. Okay, so it helps us to understand the behavior of a function at a particular point a. Fine. Now understand with example. Let's take an example and then we will understand it. Then this idea would be very much clear. Okay, so let's take an example. So example is, our f of x is x plus 1. Okay, or let's take a here to be 0. Now observe, here x is what? X is some closer value to a, and this x I will feed to our function f of x, and this will give some output f of x. Okay, so as our point is a, let's take a very closer value to a, and let's take, at first step, let's take a value 0.1, and we know that 0.1 is very much closer to a, and let's understand here like this. So this is 0 and this is 0.1. So this is the value which I took. Okay, now when we put this 0.1 in f of x, what we will get? We will get 1.1. Now at the second step, let's take a particular point which is 0.01, and now it is very much closer, more closer to 0 as compared to previous one. Okay, so the next point is 0.01. Now if I feed this point to f of x, what output I will have is 1.01. Now again let's move further closer to a. So let's take this point 0.001. Now if we feed again this to f of x, we will get 1.001. Now let's say, suppose we are very much closer to here, and suppose this point is 0.00001, and if we feed this to f of x, what we will get? 1.00001. Okay, so what you are observing here, we are observing here is, at each step we are getting closer to what? 0. Okay, for each step our x is moving closer to 0. So at first step we are 0.1, the next step we are 0.01, which is very much closer to 0, and third step 0.001, which is again more closer to 0 as compared to previous ones. So at each step we are moving closer to 0. Okay, but the main idea here is, the main observation here that lies here is, as we are moving towards the 0, if we see our f of x, so our f of x is also approaching to some value, it is also moving closer to some value, and by observation, what you can say, which value it's moving closer to, that value is 1. Suppose here is 1.1, here is 1.01, 1.001 and 1.001. It means as x is moving closer to 0, our f of x is also approaching to which value? 1. And we got by the definition that the value that our function approaches as x get closer to a, that value is what we call limit of a function. So as our x is approaching to the value a, which is 0 here, our f of x is approaching to the value 1, which is L here. So here this L is what? Limit of our function at a point a, which is 0 here. Okay, so if we write in mathematical in notation form, So it will represent, we can write it like this: x tending to 0, but x is getting closer to 0, and our f of x, which was x plus 1, is moving towards 1. So this is our notation for this particular example. So did you got the idea? So idea here is, limit actually helps us to understand the behavior of function better at a particular point. Okay, so if we take a particular point and we want to see how this function behaves at that particular point, so what we do, we feed some closer values near to that point, and we see how this f of x is approaching, or how this f of x is behaving with respect to that neighborhood points. Okay, so this is the idea behind the limits, and this is why we need limit, okay, to understand or to know the behavior of a function better. Okay, so let's understand geometrically too, how we can visualize it geometrically. So suppose, let's say this is our y-axis and this is our x-axis. Okay, and this is some function f of x. Okay, now suppose this is a point a. Okay, and for this point a, there is some value f of a. Fine. Now suppose, let's say I took a particular value which is x1 here, which is closer to a, and I got some value f of x1. Now again I move closer to a, suppose here, and what I got here value f of x2. Suppose I again move closer to a, and I am now this much near. Okay, suppose this is x2 and this is x3. Now this x3 is very much near to a. Okay, now if we take this for that particular x3, our value is f of x3. So what we are observing here is, as x1 is moving towards a, this distance is decreasing. Our value, the distance between the actual value at a and the point that we are observing is also here decreasing, as we can observe. So as x is approaching to a here, our this f of x is also approaching to this particular value, and this particular value that it is approaching is what we call L. Okay, so this is the geometrical interpretation of our limits. I know this is some kind of messy, but yeah, if you will try to understand or think, you will get the idea here. Okay, now why we also if there is also we can observe here that suppose this is a. Okay, so in how much ways I can approach a. So you can say, yeah, there is two ways to approach a. First way is from this side, that I am approaching a from this side. Second way is I take any value from here on the left on the right side, and then I am getting closer to a. Okay, so if I'm taking any particular value on the right side of a, means any value greater than a, and then I am getting closer to a at each step, then this kind of limit is called right hand limit, which is known as RHL. Okay, right hand limit. And if we are taking any particular value on the left side, okay, and we are approaching towards that particular a, this is called LHL, or left hand side value. Left hand limit. Okay, this is what we call left hand limit. So for approaching a, there are two ways, from the left side and from the right hand side. If we are approaching from the left hand side, we call this left hand limit, and if we are approaching from the right hand side, we call it right hand limit. And for this particular example, we can see this point lies where? Here. So we are approaching it from right hand side. So here this limit is what right hand limit. Okay, now if we approach 0 from here again, then our limit would be what? LHL, and this would be and I will call it left hand limit. Okay, so this is the basic idea behind limits. Okay, and about the motivation part, why we need to study limit is, suppose I give you two functions. First function is this. Okay, second function is this. Now I say, okay, suppose this is the point A, okay, and this is the point A. Now here you can see at this point A, this function doesn't attain any value. Here this dot means A is not attaining any value here. A is not this f of A is not defined, and here it has some particular value f of A. So what we can see here, this function is discontinued. This function is not smooth. There is a point A at which this function breaks, and here this function is smooth, and here this function is smooth, and it does not break at any point. So here limit helps us. How it helps us? It helps us like that. Like for example, if we are moving from the left hand side, then there is some value that it attains, and from right hand side, then there is value that it attains, and from both side what it attains is L, okay. But at A it is not defined, but we are not interested at that particular value A. We are interested in the neighborhood of A, and we got to know that okay, our f of x is actually approaching to A, okay. Now suppose there is another condition similar to that, but the idea is like this. Suppose from right hand side if we approach, we get some value 1, and from the left hand side if we approach, then we get some value 2, okay. Now if I approach from the left hand side, our limiting value would be what? 1. But if we approach from the right hand side, our limiting value would be what? 2. So here if we get two different limits from the right hand and left hand side, then what we can convey, what we can infer, we can infer that there is a jump or discontinuity, we can say, okay. So this is where limit helps us. How? By knowing the behavior of a function at that particular point. Okay, so this is the idea of limit. I think you got what limit is, what's the idea behind it. Okay, so if I do recap, so what we understood, limit helps us to understand the behavior of a function at a particular point. About the there are two kinds of limit, left hand limit, right hand limit, and about the definition of limit, the definition of limit says what value f of x approaches as we move, as our input gets closer to some particular value, okay. Now with the help of this limit, we can understand very important concepts in calculus, which are continuity, differentiability, and integrals, okay. And in real life worlds, you know, artificial intelligence, there we need heavily these concepts, okay, to train these models. So yes, limit has a real world application too. Okay, thank you.